Hey guys, my name is Jordan Rising. I am one of the founders here at Geoflow. I wanted to take some time today to go over Geoflow and show what it is and kind of how it works and give you some visuals to help explain it a little bit. There's a million different things we could kind of go through today. I'm going to try to keep it as condensed as possible and then have follow-up videos that go through things in more detail. So hopefully don't get too long here. I have I'm shooting for 10 minutes, but I have a feeling I'm not going to hit that. But um, Geoflow in general is a node orchestration software. So that might not make a whole lot of sense to many people. And in fairness, it didn't make a whole lot of sense to me even a few months ago. So don't feel bad. It's kind of a relatively new I don't know paradigm here. You'll see it in things like Make.com or N8N or Zapier. But basically, it allows you to create automations and workflows using little nodes in the UI. And I guess it's just going to be easier to show you. So before I get ahead of myself, I'm going to start our dev server. So Geoflow is open source. Um, well, it's going to be open source. The code still lives in a private repo right now. I'm getting to the point where I'm really close to getting it to basically be public. It's not quite there, probably weeks away, maybe a month away, but we're getting close. But so we're just going to run it on my computer locally for now. We have a basically the whole service is running in Docker in various containers. We have an MCP server, Postgres. The Convex is our major backend for a lot of this stuff. We have our own worker for executing point cloud processing and stuff like that. But it's just all running locally on a little MacBook, so it's not the most performant thing in the world either, but it'll do for today. Um, Actually, I'm going to go back from a high level. When you get to Geoflow, you can kind of see just a dashboard of your executions that you've run or the workflows that you've run. You can see your various workflows. You can look at your credentials, or maybe you won't look at any of that. It's the fun of running things locally. And in dev, you'll hit errors. So expect that a few more times today. But you can see the credentials. These are just mostly for AI stuff right now. If you had any OAuth providers like Google Drive or Amazon, like S3, those will show up in here too. And then, of course, what would any new app be without proper dark and light mode? You have various settings, change your passwords, all kind of stuff. But for the sake of today, I'm not going to get into that stuff. But I'm just going to call this workflow demo. I'm going to save it just to kind of activate the workflow here. But what you're first presented with when you start a new workflow is basically a blank canvas. So right here in the middle is your canvas. And the idea is you're going to scaffold together a bunch of nodes. So here's my list of nodes. And you're going to scaffold these nodes together. Kind of looks like a spider's nest or like an interweaving. I don't even know what the term is. Nodes. But you work through these nodes almost like sequentially, and you create logic gates in between them so that you can do a wide variety of things. So that was kind of a mouthful, so it's probably just going to be easier to show you what I mean here. So let's just start with a basic API one. So this example that I'll make here today it has almost no practical implication, but it just kind of shows how the nodes work. So let's make an API, so like a fetch request. So I'll do it to JSON placeholder. Let's do this. So this is just a kind of a development site. It doesn't require an API key or anything like that. So I have this one single node for this workflow, and I can execute it. So if I hit execute, it's going to run this node, and it says completed. And it only took a second or so. And if I come to the output, I can see, well, it took 224 milliseconds, and here's all the data it gave back. So it gives me back all these kind of placeholder posts, as if it was a blog or something, I think is kind of what this website's for. But it's for testing. So that doesn't do us a whole lot of good by itself. So let's add another node. We'll do a condition node. So a condition node is kind of your typical if-else statement. If you're even vaguely familiar with programming, like most programming is built on those conditions almost. If something is true, do this. If not, do something else. So that's kind of what this is. So this node will execute first, and now this node will execute second. So you can kind of see that, animated line between them, somewhat indicating that. But if I come to this node now, I can see what data I have available. And maybe I'll say, if that API call was a 200, which means that it was a successful, query, then do something. So I'll just add a debug node. I'll add another debug node. So right now, the way this works is if this API call works and it comes back with a status of 200, which means it's successful, then it should run this node. So let's do that. So this runs. You can see that this completed, this one completed, and this node completed, but this one did not execute at all because this condition was true, so it never made it to the else block here. But if we say, hey, if it's 200, run this node, now that's going to be false, so the else branch here will execute this next time. So now you can see that this one did not execute this time, and this one did. And we can add as many of these as we want. So we could say, let's add another debug node. And we'll say, I don't know, what kind of data do we have access to here? This has 5 items. Let's do that. So if the data dot length, how do you spell length, is greater than 1, so if it's got more than 1 post that came back, run this one. So we know that it should be coming back with a 200. So this first one should be false, this one should be true, and this one should never get to either. So let's run it, and that's exactly what happens. So we know we have 5 posts, let's say 6 now. So we know this one's not true, this one's also not true, but this else statement, kind of like your final default, should run now. And that's exactly what happens. So you can see how this kind of flow works. So now, depending on the situation of your automation, any 3 of these branches might run for any various reason. That's kind of the power of these automations, or like kind of node orchestration, is you can have it branch into another branch, into another branch, and do all kinds of things. And right now I'm executing this with a button that, we call that a manual trigger. But you could also start this with a schedule. So maybe instead of executing this by me hitting a button, you want to start it with a schedule. So instead of, or you come to the schedule node here, and let's say every day at, 8 a.m. Mountain Time, I want to run this. So it's going to, now if I were to save this, it'll save as one of my scheduled workflows. And every single day at 8 a.m., it'll run this sequence, this workflow here. So again, this isn't a very practical example. Like we're just getting posts from a random website here, a random endpoint. But something maybe a little more practical would be maybe you have a Google Drive. Sorry, I'm kind of moving all over here. You have a Google Drive node, and you say, connect these quick. Every single day at 8 a.m., you want to list the files with, a certain, LiDAR flight or a certain search query. I don't even have my OAuth set up with Google Drive right now, so I can't run this. But that's maybe a little more practical example. Maybe after it gets all the files in this directory, you could have another condition that says if any of them were created, today, do this, this operation. Maybe instead of this stuff down here, you have processing pipeline. So point cloud processing pipeline, that kicks off if, new files, that LAS files were from today. But speaking of LAS and LiDAR stuff, let's do a quick point cloud one, just because, I'm at 9 minutes. Okay, I'll try to make it quick. We have 2 different point cloud processing, PDAL. Howard's going to hate me for saying PDAL, but it's PDAL. It's not Poodle. I know you invented. I know PDL is your own thing, and I'm telling you what to do, but or what it's called. But I like saying PDL. So PDL app and PDL pipeline. So PDL app is when you want to run a PDL application. So in PDL, there's various applications like getting the info for a file or running a ground classification. A lot of these are actually getting deprecated. So we're not going to support a ton of applications here. Things like tile make sense and merge and stuff, but the rest we're defaulting to this pipeline, which I'll show you here in a second, and why that most of the time makes more sense. But let's run this app one or this info operation, and it's asking for what file. Now I have mounted to this directory, this data directory on my host computer. So when I specify small test.las, it knows I'm referring to that directory. So I'll save it. I'm going to say pedo app. Save it. If I execute this, it'll run and it'll see in the output kind of info metadata on that LiDAR file. So similarly, just like we did in the last one, I could say, if, let's say, the point count of this is more than 200,000, do, or 200 million, or what number am I writing there? 200,000. If it was more than 200,000, do something. If not, do something else. If it's I don't know, certain coordinate system or who knows what. There's an kind of overwhelming number of things you can do here for how to automate point cloud stuff. But so that's kind of what app does. It's kind of for just one single operation like this. And downstream of this, you wouldn't really necessarily do anything more for point cloud processing stuff. But now I'll show you the other PDL thing we have is called pipeline. And what pipeline does is all the nodes that you add that are PDL pipeline execute atomically. So as a single unit. So PDL has this concept called pipeline. And it's one single pipeline.json file that runs atomically, like I say. So it's not always the case, but more often than not, you basically bookend it with a load file operation and then a save file operation. That's kind of generically how it works. So we could have that same file, that same file here that we had. We load that, and maybe for our operation, we want to do a ground classify. It's asking what classification method to use. We'll say SMRF. There are a bunch more options you can do here, which are beyond the scope of this video. And then we could save it as an LES, test demo. This is the 880th time I've done this. Just kidding. But if you did something like that, what you'll notice when I hit execute is that all three of them will execute at the same time because it executes as this chain, as this one pipeline. So it'll create this pipeline JSON here that you see and run that. So you can probably see that in our logs here. So it created this pipeline JSON here, built the combined pipeline. It loads in this LAS, runs filters.smrf, which is the ground classification, and runs the writer. So that's how kind of the PDL pipeline works. Now this is very, very simple. What I would expect to do is, you have a ground, or maybe you'll set your classifications first, so that everything is set to, classification 0, and then you do a ground classify, and then you do, maybe a fin, and then generate contours. We're just getting started with all this, but there's a lot you can do already, and you can automate basically your way through a raw file all the way to, ground classification contours. But yeah, so this is the second way you can run point cloud processing, like I said, with the pipeline. But there is a third type of way to execute a workflow for now, and that's with agents. So this is AI agents. So instead of basically, hitting, let me just say this quick first before I start trying to talk at the same time. So instead of hitting execute to run an agent, we have a different way to interact with it, and you can chat with it. So you could say, you are a helpful GIS agent with access to GIS MCP tools. So we do have MCP tools, and we have specifically GIS ones, which is pretty neat. So we're going to enable MCP tools, and we're going to select our GIS server. So that is the this Geoflow MCP container. That's what that is. Um, we're going to specify the OpenAI key because we're using an OpenAI provider. And now the way to actually interact with this is through the chat. So I'm specifying which agent to chat with. You know, you may have multiple agents in a workflow that do a bunch of things. So you might have multiple agents to select from. For now, we just have this one. I actually copied this. Yeah, so I don't have to type it all. Waste more time than I'm already wasting here. So I'm going to ask it to create 50 points in Montana. So the first thing it's doing is it's thinking. So the agent is set up in a way that it kind of runs off this React kind of paradigm where it'll basically process your request or your prompt. It'll evaluate how it did as far as like its inference of that, and then if it needs to, it'll loop back through and redo it if it needs to. And it's kind of more sophisticated than just like a one shot. Here's my prompt, and I expect one answer. This is kind of more how an agent is designed to work here. So apparently it's done, but you can see its thought and then the action that it took. And if I come over here to my outputs, I should be able to see this test demo KML that it saved to my computer. And there's actually quite a few other things you can do as far as kind of creating visuals of these, but I'm going to save that for its own video because I'm already getting pretty far here and much longer than I promised. But that, in a general, very, very high level, is what Geoflow is and how it works. And if you have any questions, please reach out. But I'm going to try to have more follow-up videos here with more specific details and examples here shortly.